Phase lines and stability. What are they? How do we compute them? Here's an example, okay? So suppose I give you this first order autonomous ODE. Remember, autonomous just means that the independent variable, in this case t, does not occur explicitly on the right-hand side, okay? Just only in terms of the dependent variable. So what is a phase line and how do I actually compute with it? Remember, step one is to find the critical points, okay? That's by taking the right-hand side and setting that equal to 0. So I'm left with y squared times 1 minus y equals 0. That means y equals 0 or 1, okay? So those are my corresponding critical points, okay? Now remember, a phase line is given as follows. So I give myself a vertical bar. It doesn't have to be vertical necessarily. You could do a horizontal one, but the vertical one makes a little bit more sense. And I think about this as like my y-axis, if you will. And then I draw horizontal lines corresponding to y equals 0 and y equals 1. So those are my equilibrium solutions, okay? So like y equals 0 would be something here. So there's y equals 0. And y equals 1. So let's say that's somewhere right up here. Okay? That's y equals 1. Now what I do is I effectively just do a sign line for this back from like your good old calculus, single variable calculus days. So here's what I'm going to do. Choose a point below y equals 0. So say, for example, if I choose like y equals minus 1, okay? Just to make your life easy. And if I take y equals negative 1, so then what is dy dt? Okay? Well, I go up to dy dt. If y is negative 1, I get negative 1 squared. Okay, so minus 1 squared times 1 minus minus 1. Now, I don't care what the number is. I just care if it's positive or negative. So negative 1 squared is positive. 1 plus 1 is positive. Okay, so that's bigger than 0. And so what I'm going to do is everything below is positive, which I'm going to indicate as an upward arrow. Okay? So if dy dt is positive, you indicate with an upward arrow. If dy dt is negative, it's a downward arrow. Okay? And you put that on the vertical line. So let's do one in between y is 0 and y is 1. So y is a half. Y is 1/2. Okay, if I plug that in, what do I get? Half squared, always positive. 1 minus a half, again, positive. I'm going to get dy dt is positive. So that's going to be an upward arrow. So here I'm going to have an upward arrow. Okay? Now let's choose something bigger than 1. Say y is 2. If y is 2, then what is dy dt? Okay, let's see. If y is 2, 2 squared is positive. Fine. 1 minus 2 is negative. Positive times negative is negative. So that's negative. So that'll be a downward arrow in this case. So I'm going to have an arrow pointing downward going this way. Okay? So now for the stability is actually very simple because once you have the phase line, it tells you immediately what your critical points are in this case. So what do these things mean? This means that if my initial condition started down here, it means that my solution curves are going to do something coming into that line like this. Okay? So depending on what my initial conditions are, things along these lines. Okay. These things shouldn't okay, so I'm being a little fast and loose here. Okay, maybe I should make this a little bit cleaner and make these kind of look like a single family of curves. Okay, so maybe they do something like this. All right, I should be a little more precise about all this. But the overall picture is that if I start down below, I'm just going to get sucked into y equals 0. If I start somewhere up here, what does the arrow tell me? It tells me I've got to be going up. So it tells me I'm going to be getting things like this, potentially. Okay? I'm getting pushed into y equals 1. Now, if I started up here, my curves are doing things like this. Okay? I'm getting pushed into that. So then what do I notice? I notice that for y equals 0, if my initial condition is slightly below 0, I get pushed into 0, but if it's slightly above 0, I get pushed away. So what does that mean? It's like on one side I get pushed in, on the other side I get pushed away. Y equals 0 is what's called semi-stable. Okay? It's semi-stable. It's only stable on one side. Okay? Whereas y equals 1, what do I notice? If I start with something slightly below 1 and slightly above, I always get sucked into 1. So y1 is stable. Okay? That's stable. Now, if you had something where you had a critical point where on one side above it, it goes away, and below it, it goes away, then you would call that unstable. Okay? So that's what a phase line is. That's how you find it via the critical points, and that's how you draw the corresponding phase line. Okay? The phase line is really just this vertical side of things. Okay? But we're putting in these horizontal lines to indicate what the potential solution curves are doing at that point and to analyze the stability. Okay, so hopefully that helps you with your phase lines and stability. Again, like, subscribe, all the things, share with your friends, comment down below, and we'll keep going.